Hi, Sportster Paul here. We're looking at SolidCAM, computer-aided manufacturing, makes G-codes for your milling machine. And we're going to look at their iMachining, which is their brand. They patented it years ago of adaptive toolpaths. Some people just call it high-speed machining. I heard, when I lived in California, I heard that it was invented down in Los Angeles by the aerospace people, TRW, all those folks, who learned you can roar a spindle through aluminum if it's spinning fast enough. And then what iMachining and these adaptive other programs have, this adaptive toolpath, not patented like iMachining, but they have them. And the theory is like you don't make any hard corners because that brings the whole side of the tool up against a curve that, has a big chip load. So it makes swoopy, kind of circular, swoopy cuts. So SolidCAM has 2D iMachining. That's part of the base package. And it's got 3D iMachining, that's a couple grand extra, a little less with the deals. Everybody gets a deal. Talk to your salesman. All right, so let's go up to SolidWorks. I started making the whole part. This is the same part that my buddy Dave Rui made, mechanical engineer, industrial designer, machinist. Made this part to trip up CAM systems, and it's still doing it, even in this session. Watch what happens. So I've got SolidCAM enabled, the add-in, so that gets you this. I've done the stock, right? So the same stock we did in the first, second, third impression videos. Go operation, add milling operation, 2D iMachining. Gotta wait a minute, and here it comes. So one of the issues I have, all the dialog boxes are different from one another. So this is different than the 3D roughing. And that was another realization. All this iMachining is a roughing kind of operation. So they're not going to be able to go perfect to the edges, which bothers me. I'll show you. Watch what happens. Okay, geometry, like again, everything's got to be different by faces, by chains, outside feature recognition, chain without feature recognition. So the last time I tried this, what worked good, I did this to say, by chains like we're used to in 2D stuff. Then go here, and I just want to do the inside of this pocket. So let's see, if we pick here and be on the left, it would be climb milling. So do that. Oh, and it fails because I forgot. Okay, go here, take constant Z off, take tangent proposition. I'm not sure. Maybe take that off as well. Show chain on work plane, smart face. Let's try it again. Okay, so now it does, this little arrow means that's where the direction of the tool is going to be. So when you say left, it ends up being climb. This says where it wants to go next. And so here you can just go over to the left edge of this chainless business. This adds it, and if you want to change the direction it's going, not pertinent where it is now, 1, 2, just go all the way around. And this should contain this 3D machining, this iMachining. I'm sorry, it's not 3D, it's 2D iMachining. Look, there's two little ones here. It catches them both. So this is when you love SolidCAM. Say yes. Let's call it deep pocket boundary. Except spell it right, boundary. I think we're all set. Go here, it already exists. Okay, deep boundary 2. I've been practicing, so it had, although it doesn't show it as a choice, but apparently it had it somewhere. Let's not worry too much. The tool, once again, completely different than the 2D stuff. Right? Well, it is 2D. It's just different because it's iMachining. So you have to go over here and select. Now you're back to where, the normal confusions of, okay, import the tools. I happen to know if you go up here, master SolidCAM, master tools for aluminum, number 25, is it thick enough? 25. And then you got to remember to go here and say next free tool number, and then you won't be able to see it, but way up here, I'm closing out of the box. There's our 1/4 inch carb. Oh, I already had it. Darn. Well, let's delete this tool. I forgot I was practicing with this. So then say select. Okay. But I did want to show. Now, I went through, okay, let's start with the 3/8 tool. and say multi-tool and do all this. It is multi-tool up here, right? I did all this, but all it ended up doing was making another operation here to do the rest machining, right? To take the 1/4 inch tool. So to show you the principles, I'm just going to go 1/4 inch straight away. Levels. Upper level is not that. No, the upper level is 0. Okay, the pocket depth is only to here, right? Because this outline, we can't carve this thing up. So that's our depth. Technology wizard. This is how hard the operation is going to be on the tool, right? 8 means you're really hogging through it. If your machine is weak, like my little router based thing, 3 makes finer cuts. It'll start lowering the depth if things are getting too hairy, too much tool path. So that was that. Technology. See, everything's always a little different. Now let's try to make this cut perfect. Even though it's a roughing thing and everybody intends to leave material on a roughing, so the surface finish, you're going to see how swoopy this is. So there'd be a goofy surface finish where it enters and leaves. Notice it went back and put the 5 back in. I can't wait to watch the video and see when that happened. I thought I had everything right. Step over. This is what all supposed to be automatic, right? Although it does let you, I don't know if you could adjust it. If you say step down, no, it won't even let you pick. I don't know. Link, this is all going to be okay. So let's pull this off so you can watch the tool paths being made. I'll pull it up above my headshot. One of these two, save and calculate, save calculate with all related operations. Do that. Doesn't take too long for this, but it's not instant. And there they are. And you can see it's hovering over here. Now, I've got to get this back where we can deal with it. So let's escape out there. Looks pretty good, right? So now it keeps pushing over. Hide the toolpaths and do the magnificent simulator, their beta simulator. Take compare function off, and as fast as we can go, because you don't want to wait. I might speed this up. I did see down here is the machining time, 9 minutes. So it took 9 minutes to do this. Now turn on compare. See, so I think if you enter and leave the dialog some way, it goes back to leaving that stock allowance on there. It just happened in practice. I thought I just forgot to do it. Let's start again. And let's go to technology. See, it keeps, okay, let's zero them again. And now make the tool path and watch them to see if it stayed 0. Okay. I'm glad you saw this because I thought I was losing my mind as I practiced all day and I practiced yesterday. So this is included. 2D iMachining is included in the base package. So now we're going to drop out of this dialog box. Once again, see it keeps pushing off to the side. I guess they want you to work like this. So, 1982 orthoscopic software. Here, SolidCAM beta. Turn off compare, zip through this. Now let's look at compare. Okay, so what's encouraging is it got all the sidewalls right. It got the depth absolutely right as we commanded it, but it gives up in the corners. And it's got a fairly substantial, that color purple seems to be here. So between 4 thousandths and 10 thousandths error. That it just refuses to do the corners. But this corner is 0.26. That's how Dave designed it. So the tool doesn't come to a dead stop when it does them. There's a tiny little arc. 2D iMachining refuses, and I looked. Close. Let's change the name of this thing too as it comes up. Things get slow. I don't know why. Change it to deep. Darn pocket. Deep pocket. I looked and looked. Is it a tolerancing? There was something about arcs. Oh, and miscellaneous arc fits. I played with this, saying, "Oh, that's got to be it." I arc fit. Didn't do anything. So I gave up. You should give up too. Okay, so now we want to do the shallow pocket add milling operation, 2D iMachining. Even though the contours are made from previous tries where this thing wasn't behaving, I want to recognize edges and chains like we normally do. I want to go here. This will be shallow 2.0. Let's see if it'll take decimal points. Chain list, come down here. You say it's not constant Z, and you don't want it to propagate tangent. And you don't start here like I did once. You start here, and then come to this button. This is what's cool about this program. I think MasterCAM is similar functionality. Now you use the change direction, go down, change direction again, go over, change direction again. Can you see what we're doing? Change direction again, except go up. Then I happen to know you got to change once. You can't see because they're tangent, but now it's going to go on the circle instead of that straight line. Go again, 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 again. Change direction down, change direction over, change direction up, and it's a closed chain, which is very comforting, right? You say, okay, shallow 2.0. The tool, different dialog box every time. We go here, say yes, 1/4 inch end mill. Levels, we want upper level to be here. We want the pocket depth to be down here. Technology wizard, not too aggressive. You know, this is how big a cuts it'll take. Here and here, I found this kept reappearing. It's like that bug I had in Visual Mill. And then let's see if it'll make a toolpath. I might have some serious problem here. No, see. So okay, I tried to do a shallow pocket. I rebooted the machine, new part, you can see the part 0 is different. It won't make a shallow pocket. Maybe you can't have 2 iMachinings. It just kept saying can't simulate and make G-code. I gave up. I'm sorry. I'll just do a regular pocket if I have to. So now let's do 3D iMachining. Now this is extra cost, like $2,000. You get a deal. It'll be a little less. So here, add milling operation, 3D iMachining. Comes up. Now here, the target is just the part, right? And just like in 3D roughing, it's boundary. Well, here it's all different, probably in a different place. You go working area, you say define. You click working area, you say define. Now we're in something. Here's a good boundary. So I changed this right here. And we want to keep this iMachining inside here. Otherwise, it'll do everything. It'll go up here and do stuff I didn't want it to do. But let's say we just want to do the deep pocket, but account for this shelf. That would be a cool thing. So where are we? We go... Don't propagate, and nope, and it's not constant Z. Pick one like over here. Okay, that'll be climb milling, and then just go around and accept the here and here. Say yes. So now it's got a boundary. Say okay, it's got a boundary. Tool, once again, see, different dialog than normal. We only have one tool and we're going to use it. Levels, this is always great to teach. The top level is actually the stock box, right? Where can you see me? Right up here in this corner? Because if it's doing all this math to figure out how heavy a cut to make, you want to account for that 1/10 of an inch above the top of the part if it hasn't done it properly. The lower level, see, is going down an inch. That's a mistake. See, it just looks at the model, say, well, the model's an inch deep. That's how deep I'll go. Technology wizard, fairly moderate. Technology, this is where it seems like a 0 better than a 0.0. We'll see if that changes, and we'll pull it off to the side now, so you can watch stuff, and we'll go here and say do its thing. See, now it works. I practiced once before I turned the camera on and did all this other stuff. It's doing its calculations. Pretty involved. And there they are. And notice, let's just get out of this dialog box. Oh, what did I do wrong? See, it's going out on the edge. Oh my gosh. Here. All right, nothing's ever simple with software. And 3D rough target, this is 3D deep pocket. I think it might have been in geometry, it might have been in this definition here, internal. See, I've been playing with this for days, so let's try it again. I don't mind this where you can kind of converge. What I do mind is when it says, oh, we can't do anything. I think it did the right thing, didn't it? Yep. Okay. So more goofiness. I mean, a boundary isn't a boundary. Inside, outside, who knows? I guess you got to tell it which direction the boundary is. So that way you could do like a boundary, what we just did, and then this outer one and expect it to iMachine 3D all of this stuff. But it won't quite do it as nice as we did it by hand. So that's good to see. Let's delete, go here, do our fantastic simulator. I do love this simulator. Take the compare function off, and now you'll see, I think we zeroed everything, right? We didn't ask for a stock allowance on anything. So it's doing its thing. Well, that was quicker than before. That's interesting, isn't it? Okay, so it leaves the same stock, and I guess I was first very upset by this, but I was like, okay, it's roughing, and nobody thinks roughing should go to exact. So it leaves material there, but see, this is what's much more serious. If you're roughing, and I can't find where to clean this up, see, it goes in and out. This slot's wide enough to fit this 1/4-inch tool. It just doesn't want to. And I searched and searched and searched. Is it a tolerance? Is it, where can I make this thing be accurate? I can't. So now I'd have to do another operation just to run a little end mill in there and rough it, or do it with hopefully just carve it off with a finish pass. So that doesn't thrill me, I'll be honest. Okay, so that's enough for this part. Let's go real quick. Hopefully I haven't burned up too much of your time. Let's go open up that oil cover, that oil container part. How are we going to do this? Shut this down. It always saves. If you open a part and say accept the SolidCAM part to open, when you close that SolidWorks part, even if you haven't touched anything, it will update the file date, which might mess up your open. Let's see, hopefully we have this. Oil reservoir, iMachining. This one should be a little bit started with the stock in business. See here, right? If you want to do a save as, don't say okay, because SolidCAM holds its data structure, and when SolidWorks goes to make a copy of your part, save as a copy, it fails the model. So then you cancel and do save as a copy. But we're okay. We want to open this. We are in SolidCAM. I stripped it back to everything. The stock is here. Let's get it so I would have it in the vise. And we did this in the SolidCAM 3D roughing and surfacing video. So we can turn that off. Operations. Add milling operation. 3D iMachining. Geometry. See, it'll do everything, because when 3D, the target is the solid model. So we have to define, it's going to be internal. We learned that just a minute ago. We got to click on working area so you can say this. We're here and we're going to say 3D boundary, just because I always like to label stuff. Then now I think you can just go here. And it goes around. Now it does have a direction, but I don't think that has anything to do with how SolidCAM does its thing. You say yes to accept. And what's interesting, see, there's these little cutouts I had for bolt heads that are in the case half that have to clear here. A little kludge. Obviously I need more work. And if doing 2D, it's kind of a pain. You got to use that up and down and go and get this curve, go down, over, back up in these two places. With 3D iMachining, it's smart enough to do that. So we say, okay, we like that 3D boundary. We say, okay, we've done our boundary work. We've got inside tool. Once again, it's different than the other dialogues. We've got our end mill. Say, okay, because I did this already 3 times. Levels. upper level. Upper level is actually 0 because, well, let's do it this way. And lower level, we want to go all the way down to the floor, right? Notice we picked the floor of the part. Then technology, once again, I found just plain zeros work better. And let's see if it'll make a toolpath or if it'll croak. Okay, I sped that up, or jumped over it actually. And so you can see it's doing some pretty cool stuff, right? You can see because there's more paths. This is a 2-pass. It should have gotten this, yeah. See how it's floating? There's some toolpaths up here to do these cars, and you're all excited. I was like, oh, cool, I've got this thing figured out. And you can see in Technology Wizard, see number of steps, 2 steps, because for some reason it decided to go down twice on a very similar kind of operation. But let's get out of it, and we're going to finish up now. I won't bother you much more with this. We're going to do the SolidCAM simulator. Once again, I'm going to jump ahead. Take compare off, and I'm going to jump ahead. Okay, we've jumped ahead. One thing I should have been saying in all these shows, I just noticed it myself. Down here, down at the base, can you see that? The time. So this is going to be an hour and 6 minutes, well, hour and 7 actually, of machining time. And you can see the staircases. That makes sense, right? It's a square end tool. If I used a ball mill, which I did once, and it leaves these really cool scallops down here, but it's not to print. But this is what's going to, okay, it's a roughing operation. Now, the first pass, it did green. It did to the true outline. The second pass, and I tried and tried to find what's going on with this, it left this dark purple. That's over 10 thousandths step, halfway down, for reasons I can't understand. It got the floor of the part correct. Then similarly, you think, oh, floors it gets, no, the floor here and the floor here, it left at least, what, 10 to 20 thousandths, according to the color codes. So these are the kind of episodes I'm having with iMachining, 3D iMachining, all the iMachining. You know, I'd rather have it a simpler kind of thing like Visual Mill. You click with Visual Mill, you just click and say, okay, I think it's HSS. So, and then it kind of starts and does circles and works out, and you control how deep the cut is. You control the step overs. iMachining's got a big algorithm and it's doing fancy stuff, but I just as soon have a little more control of these adaptive toolpaths, at least to get it so that it's cutting the sidewalls right. So that's iMachining, 2D and 3D. Sorry, you know, the 2D of that second lower pocket, it's just I tried for an hour to get it working. Couldn't, it kept saying, can't, you know, no toolpath, can't simulate, no G code, that kind of error. I don't know. We'll figure it out. All right, enough for SolidCAM. We're going to move back over to BobCAD next probably, and then make some choices. Visual Mill, BobCAD we're going to look at and see what we like. Powerful program, a little hard to use, and expensive. So we'll see you next time, all right? Sportster Paul, bye now.